So how does an equilibrium system shift in response to changes in pressure and or volume? We just talked about changes in concentration. Well, it's all related. So let's examine the same system, nitrogen, hydrogen, ammonia, and let's pretend that we have it in a closed cell vessel like this with a piston on top. And the piston here is sealed, and we can just put more force on that, and by putting more force on that we have control over changing the volume. And you know from your ideal gas law that if we decrease the volume of a chamber, then of course the pressure is going to increase as well. So we're really changing the pressure by changing the volume. So if the system's at equilibrium and it's nice and happy, and the concentrations or the partial pressures of each of these things are all fixed, they're unchanging, and then all of a sudden we start to maybe decrease the volume by half. So that means we double the pressure. How does the system respond? Well, we need to think about what we have in the system and how those relate to the reactants and the. So the way that this is written, you can see that nitrogen, hydrogen, and ammonia are all gaseous. And remember, changes in volume and pressure only pertain to gases. So we need to identify how many moles of gas we have on each side. Because if we change the pressure, we are going to change the compression of these things differently if the number of gas moles is different from reactants to products. So we can see on the left, we got 1 mole of N2 and 3 moles of H2. So we have 4 moles of gas that are reactant, and then we have 2 moles of the NH3 gas. So how does that respond? Well, if we think about this naturally, how would the universe want to alleviate that tension? If you start to compress gas into this cell, which way could the system shift to try to relieve that tension? Well, it's going to shift in the direction that has less gas molecules, right? Because that means it's less pressure in the system, and that's exactly what happens. So we'd end up with this system if we were to decrease the volume, or that means increasing the pressure, then we're going to push the system towards the fewer number of gas molecules. Same would be said in reverse. If we were to decrease the pressure of the system by giving it a larger vessel, more volume, the system would move backward to have more gas molecules in that space. In balanced reactions where the number of moles of gas molecules is the same on both sides, then there's no effect of changing the volume or pressure in this system. One last scenario is what happens if we change the pressure not by changing the volume, but by bleeding in, say, another inert gas. So an example would be, well, what happens when we have this bottle here of argon gas and we just pump in a bunch of argon? How does that change the system? Well, it turns out that doesn't do anything, because if you think back, these molecules are defined by their partial pressures. Their partial pressures are unchanged even though you're adding a whole bunch more of these molecules. Their relative partial pressures still remain fixed. So we're not changing anything when we add pressure by adding an inert gas. That doesn't do anything for us.